Shoksha, and today I'll be presenting on benchmarking of machine learning algorithms for SLA systems. So these are the main topics. First is machine learning for SLA system, then software implementation, data and input data set, and then outcomes, and then conclusions. First, let's talk about machine learning for SLA system. So these are the 8 machine learning algorithms that we decided to work on for our SLA system. They are linear regression, logistic regression, decision tree, k-nearest neighbor, naive Bayes classifier, neural network, random forest, and SVM. When it comes to linear regression, it's a simple regression analysis, but it works really well for numerical data. When it comes to logistic, we usually use it for classification, and we use logistic function over here for regression analysis. In this decision tree, it goes from observation about an item to conclusion about the target value. In k-nearest neighbor, we try to search for similarities and group them. In Bayes classifier, it is mostly the calculation of probabilities, and we assume that the target value is conditionally independent. Neural network is, like its name suggests, it is based on the neurons of brains. They are general function approximation. And then it comes to random forest. Random forest is basically multiple decision tree that we merge together to get better accuracy for our result. In SVM, it is a discriminative classifier formally defined for separating hyperplanes. So for these different algorithms, that we decided to work on, they have, like you can see, most of their training speed is pretty good, except for neural network, random forest, and SVM, because of their layers, and there are like multiple decision trees. The prediction speed is also pretty good for all of them. Everyone is fast. In decision tree, it depends on the number of nodes, whereas the random forest is sort of moderate. In problem type, you can see most of them can do either, but logistic regression does mostly classification, naive Bayes does classification, linear regression just does regression. Let's go through the software implementation of the machine learning algorithms. So these are the steps that I specifically follow for whenever I implement any machine learning algorithm. So my step 1 is to determine the objectives, like what is the goal, the metrics, and the constraints that for a specific algorithm. Then I go for accessing data, because the data cannot be directly fed, because there are outliers, there are lots of features that are not necessary for the outcomes that we need. So I went up cleaning all the data. Dr. Rusko provided a really great data set. It was pretty much structured, but still I had to do like a couple of changes so that I can feed my model. And then after I get the data, I feed that data to my model and train on it. So if you just go through here quickly, this is my linear regression machine learning algorithm. Over here, I import necessary libraries. Over here, I distribute them in test data set, and over here, I distribute them in features and the target, and then I split them in test and training data set. Then I call the linear regression from scikit-learn, and I fit them, train it with the training data set, and with the train model, I predict the outcome from the test data set. And then I do a bunch of plots so that I can understand how it is performing. and then I feed all the output to an Excel sheet. Same goes for neural network. Again, importing and distributing into features and output. Then there were like a couple of hot encoders that I had to do, and then splitting the data into train and test. Then there were a couple of layers for neural network that I had to create. And again, the training, after training data set, the prediction that I fed to a Excel sheet. So let's talk about the input data set. So this is the data that was provided to us by Dr. Yuskov. And over here you can see like there are like for every assignment there are like different test 1, test 2 in class activity. So he has provided us really with really good data set, and they have been like over here it is mentioned like what percentage they each of them are getting, and what is the max what is the max and what is the actual score that they are achieving. So this is basically data set that we got, and there are like 5 years of data. So after I processed it, I started cleaning it, and this is what I ended up with, so that I can easily feed it to my models. So I just converted everything into percentage, so that I would just directly feed them as a percentage. And there were a couple of features that I had to exclude because they were not there, like the extras one. But moreover, the one which has good weightage for the final score, those are all of those are mentioned over here, and this is the entire data that I feed to my models. There are like in total 83 data. So yeah, total 84 datas. And then after feeding data and training them, I got my output. The output is something like that. Over here you can see linear regression performed really well when compared to the others. The decision tree was good, random forest was pretty good, SVM was good. But again, when I tried for classification, they were not performing really well. I have to work on them. I'm still not sure why my logistic regression is not performing well. The error you can see over here again. For classification, the errors are really high, but when it comes to the linear regression, decision tree, they are doing pretty good. These are the outcomes that I get from the test after testing my models. So over here you can see there's 3.7% error. For decision tree there are 8.35 error. But neural network, it was real. There was a lot of error, so we need to work on this. So talking about conclusion, I see linear regression is the best for us for now. The second conclusion is that again the classification algorithms are not really not working really well for our small amount of data. Maybe we need more data. We really need the third our conclusion is like I think we really need to find out ways that if we can augment the data that we have, so that we have more data to like train our model and test on it. The fourth conclusion I see is because of small amount of data, not very lot of student got C, D, and F, because of which the model totally neglect those grades, and only all the outcomes are only in A or B. So we need to see how we can tackle them. Apart from that, the next step would be research. We have to research more on machine learning algorithm. If we find something really nice, or that would work for us, and then we have to increase their accuracy. So that was all. Thank you very much.